I want to talk about taking derivatives here and trig identities and how they play a part. I look at a function like this. I want to take its derivative for whatever reason. The derivative is, now this is a product of two things, so I'm going to use a product rule. I've got the first function times the derivative of the second function, oops, plus the second function times the derivative of the first. Well, now take those two derivatives. I've got sine x times derivative of sine x. Derivative of cosine x is a negative sine x. So I'm going to put the negative out here. And then I have cosine x times the derivative of sine x, but the derivative of sine x is also cosine x. So anyway, I'm going to write the cosine squared first here, just because it's easier for me to write it like this. So here is the derivative of the sine x times the cosine x. It's this thing right here. However, if this were a problem out of the book and you looked up the answer in the back, you may not see this as the answer. What you may see is this. There's a trig identity, one of the double angle formulas for cosine, that says that cosine of 2x is equal to cosine squared x minus sine squared x. And so it's quite often the case that textbook authors or publishers probably want to save as much ink as possible and conserve space on the pages, and so they're more likely to give an answer looking like this than that. So you may find this happening quite a bit, where you work a problem, you get an answer, and it doesn't match the answer in the back of the book, and you're like, oh, I got it wrong. Well, if your answer doesn't match the back of the book, there's a couple of possibilities. Either both answers are right, or both answers are wrong, or one is right and one is wrong. One thing you can do if you don't immediately see a trig identity or the algebra that would convert this into that is take out your calculator, draw the graph, have it draw the graph of your answer, have it draw the graph of the book's answer. If the graphs look the same, then you've got the same function. Okay. Another thing that may show up here in some of these problems is that if you actually had, at least at this stage of the game, and this is just a game, right? If you had this, and they want you to take the derivative, g of x is sine of 2x. At the moment, we don't have a rule for how do you do sine of 2x. We have sine of x, and what does the 2 do? I mean, the very next section here this week is the chain rule, which will allow us to do this. But one of the options that you have, in fact, the only option you have, if this problem were given in this section about trig functions, then before you take the derivative, what you need to do is actually use the double angle formula for sine here and write this as 2 sine x times cosine x. And then you can now take the derivative of this thing. G prime of x is equal to, well, the 2 comes along for the ride, and then I've got a product of those two, which is sine x times the derivative of cosine x, which is negative sine x, plus the cosine x times the derivative. Well, I mean, we just did this, right? Cosine x. And I end up with 2 times cos squared x minus sine squared x, which, I could leave like that, or I could use the trig identity and write that as 2 times the cosine of 2x. Okay. So beware that when you look at the answer in the back of the book, just because your answer doesn't agree with theirs doesn't mean you're wrong, right? You may choose to write it one way, they may choose to write it the other way. You got to just be able to tell whether they really are equal to each other or not.